Hello, class, and welcome back. Today, we're going to focus on Aeolian processes. Those that are the processes we find in the desert. We'll expand upon that too. We'll be looking at the landforms we find in arid environments, including those carved and deposited by wind. But we'll also be looking at other processes within the desert environment. So on we go. So arid lands, processes, and landforms. We're going to take a look at some of the landforms you might be familiar with within a desert environment, especially here in the western states of the U.S., from sand dunes and arches and slot canyons, etc. So let's get into this right now. So the desert landscape that might come to mind, if you were just to say the word desert, what comes to mind? For many of you, it would be these big uh, rolling mounds of sand dunes, which we refer to as ergs or sand seas. So an erg or a sand sea is just endless mounds of sand in a dune form. Uh, to be honest, they have to cover 50 square miles to be called a sand sea. But some of you have experienced environments like this, maybe on the way to Vegas. You can look off to the side and see these sand dunes. But they're pretty rare in the desert, to tell you the truth. So sand surfaces only cover about 20% of the world's deserts. Most of the world's desert surfaces have other coverings, not sand. So if you get a chance to explore sand dune fields, feel pretty lucky. Um, there are people who have taken their snowboards. I'm sure it's not good for the snowboard, but gone for a ride down the face of some of these sand dunes in the Mojave Desert. Um, that's something that would be pretty interesting to do. I haven't done that yet. I've snowboarded, but not on sand. I don't think my snowboard would appreciate that. So maybe an older board. Another desert landscape we see, very much more common, is referred to as reg, or desert pavement. And you can see in the image over here on the left that it's kind of a stony surface. And what's missing? Well, sand. So what's happened in this case is that wind has blown over a surface that contains sand and pebbles and gravel, etc. The wind has been strong enough to remove or deflate, keyword there, deflate, the sand grains. So removing the sand grains leaves only this pebbly surface behind, protecting the layers below, the layers of sand. But on that surface layer, we can see lots of gravel, coarse sand, and even larger pieces of rock material. So a surface like that is referred to as reg, or desert pavement. And the process of removing the sand is referred to as deflation. And remember, if the sand is removed or eroded from that surface, the sand is still there. We have to account for that a little bit later on. Now, we also see desert landscapes like hamada. So hamada are arid landscapes dominated by bedrock outcrops. So we're not talking about a sand surface. We're not talking about a gravelly desert pavement, but instead here, desert with bedrock outcrops dominating the landscape. So the ergs, or sand seas, the reg, or desert pavement, and the hamada are very common landscapes in arid or desert environments. Another thing we see in the desert is desert varnish. Now this is a dark magnesium and iron staining of rocks that we see from the interaction of the minerals and bacteria. And it takes a long time for this to form, so this is often used as a way to date or to see how many years a certain desert surface has been there undisturbed. Now we can see that a lot of Native Americans in the arid Southwest used this desert varnish as a base to scratch in or carve in some petroglyphs or rock paintings. Now, one thing that comes to mind in the desert is wind, but to tell you the truth, wind is not the dominant force in sculpting the landscape in a desert. It's actually water that does that. So anything involving water we call fluvial in terms of erosion. So where wind erosion is referred to as aeolian erosion, Water erosion is referred to as fluvial erosion. We're going to have a whole chapter on that coming up. Now, fluvial erosion in the desert comes from those very rare flash flood events that we get. And what that means is that when we don't have the water, or we don't have much of a water presence, we still have a lot of physical and even chemical weathering occurring in bedrock environments. Like, let's say up in the mountains, there could be some frost thaw action. There could be some salt wedging taking place, but that material hasn't been flushed out. So these occasional heavy downpours that we find in deserts will flush out this weathered material through canyons and out onto the desert floor. And this is often done in the form of debris flows, which we talked about when we discussed mass wasting. So debris flows through these narrow canyons, flushing out this accumulated material out onto the desert floor. And of course, the heavier stuff won't travel quite as far as the lighter material or finer grained materials, which will make the way all the way down to the desert floor. So often in the western states, you can go to some canyons within an arid environment and find very narrow or slot canyons. There's evidence that water has flown through here with some velocity because of the presence of these boulders and sand and gravel deposits at the very bottom. These are actually very dangerous environments if you don't know what you're doing, because there could be a storm tens of miles away, and the water from that storm could find its way down through this canyon with very little warning. Now, when it goes through the canyons, of course, the water is traveling pretty fast, picking up that accumulated material over many years of weathering and basically flushing it out onto the desert floor. You can see a recent example in this photograph here of material that has been deposited out of the canyon and onto the desert plain. In this case, making a fan-shaped body called an alluvial fan, because the material deposited by water in this fashion is referred to as alluvium. So here's a fan of alluvium or an alluvial fan. Diagram, photo. So basically, we do get erosion and a flushing out of materials from the canyons, and then they get deposited onto the floors of deserts, making these alluvial fans. And sometimes they will even coalesce into, basically, they run into each other. The finer material and the water itself can make its way all the way down to the desert floor itself, where the water will evaporate away and leave salts behind, or very fine clay materials, those that have traveled the furthest from their source to where they were ultimately deposited. Within that alluvial material that has been deposited, we can get further incision by some of these storms. The water running through, cutting down into the loose material, creating arroyos. That's another feature, an arroyo that we find in a desert environment. So here is the playa. This is the material that is deposited the furthest from the source. This can actually be an area of standing water immediately after storms. The water evaporates away, leaving behind a very flat plain of silt, clay, and salts that have evaporated away. So a desert playa is not necessarily a, a cool place to hang out for your vacation, but some people just love that environment of being in the desert at any times. And playas, or at least they're quite interesting. You've got to make sure when you're out there that you have plenty of shade and plenty of water, because as you can see from the photos here, you're completely exposed to the sunshine on these particular desert environments. Now, in the southwest of the U.S., we have some very unique landscapes because we have an area of bedrock, of sedimentary rocks that have been uplifted over the last several hundreds of millions of years, exposing various layers of bedrock, which have then been incised by river action. So the river is incising into these materials as they're exposed. So uplift of this plateau area, downcutting by a river, and unique landscapes and landforms are exposed in this environment. We can see beautiful areas of canyonlands where resistant rock layers form or help form vertical cliffs, and then more shallow sloped areas where the rock is more easily eroded. So we have resistant, let me click out of here for a second. Resistant layer more easily eroded, resistant layer more easily eroded. And this could be a matter of some layers being limestone, some are being sandstone that's very well cemented, or it could be shale layers that could be more easily eroded. So basically, depending on the geology, you would have a different landscape, or sorry, a different slope, creating this overall landscape. I am back now. So some of the features we would see here would be things like pinnacles, buttes, mesas, and plateaus. And again, I better hop out of here. As you can see, a plateau has quite an extensive horizontal element compared to a pinnacle, which is really just almost like a point. So a pinnacle, a butte is wider, a mesa is even wider, and a plateau, of course, is a very wide feature. So we're seeing buttes, uh, mainly pinnacles and buttes in this photo right here. Now, in the desert, we also see that once sand has been deflated from a surface, it gets carried in the wind. And as that material is carried along in the wind, anything it runs into gets abraded. Now, abraded means scratched. So we can see landforms like hoodoos, and sometimes features called yardangs, where the lower few feet are etched, scratched by the sand being carried in the wind. So in this case right here, we see erosion of this level. Now the sand, because sand has weight, and sand grains are much larger than silt and clay grains, the sand can't travel more than a few feet from the surface. It can't get lifted too high. And that's why we see a lot of abrasion taking place in the lower few feet, creating these very unique landforms in the desert. These ones here are called hoodoos. Sometimes they're called rock goblins. We also see the formation of arches, largely from water erosion along certain cracks and narrow canyons that basically over time they get larger and larger and larger. Then we get the collapse of certain areas, but arches might remain for quite some time. Now this one here is quite delicate in nature, and maybe at some point in the very near future that will collapse and no more arch. So that's an ongoing feature within the deserts too. So back to that process of sand being deflated from the surface. Now, as the sand moves downwind, some of the grains are going to roll across the surface. We call that creep, that process creep of the sand grains, especially the larger sand grains moving along the surface. Fine sand, medium sand might bounce along. So just a few feet of hitting a grain, bouncing up, gravity pulling back down, hitting another grain, bouncing up. So sand tends to bounce along the surface. So bouncing up, we call that saltation. So sand can creep along the surface. It can saltate along the surface, or the finer grains, especially those very fine sand, silt, and clay, they can be suspended in the air for quite some time, maybe even to 100 feet, 200 feet, or more. The finer the grain size, the higher it can be suspended in the air. For instance, in this photo here, we have which some people might refer to as a sandstorm, but that would actually be a misnomer because the sand cannot get so high as shown in this photo here. The highest grains that we see would probably be clay size, maybe even very, very, very tiny pieces of silt, but even that would be a stretch. So we call this a dust storm rather than a sandstorm. So sandstorms, the sand can only travel near the surface. The finer particles, silt, clay, even finer pieces in clay, we refer to collectively as dust, so that would be a dust storm. Now it's the sand that's going to do a lot of the erosional crafting or carving within a desert environment, less so the silt, clay, and finer particles. So again, earlier we talked about the process of deflation, of wind picking up the sand grains, and then those sand grains will roll across the surface, right? They'll creep along the surface. They will saltate along the surface, and the finer particles could be suspended. But it's those pieces of sand, those grains of sand, which are bouncing along for a few feet, even in very strong winds, that are going to do an awful lot of the carving of aeolian features within the desert. So take away the sand from this desert pavement, move it in the air, largely through saltation of the sand-sized grains, and then those will do some erosional work, carving out these unique landscapes of hoodoos and yardangs, which are larger hoodoo-like features, and finally being deposited. So we see erosion, transportation, and some of the erosion done during that transportation process, and then finally deposition of those sand grains. So let's account for the sand itself. So again, sandstorm, the sand is saltating along. Dust storm, those finer grain particles are suspended in the air. We do, to be honest, you can get sand moving a little bit higher than the surface if it ramps up along a sand dune. But we're talking all things being equal here. Dust storms, the dust particles, those can move higher, but the sand-sized particles are going to stay sort of towards the lower few feet. So here's a yardang. You can see here this area has been carved by the saltating sand, and those grains have abraded away some of the material that would have existed here and here in the past. By the way, if it looks familiar, if you had enough time, you could go and carve something out of that. Well, in the Egyptian desert, we see a very, very famous example of that with the Sphinx. That was a yardang that was then carved into the Sphinx feature we see today. One thing to keep in mind when we're looking at when sand gets deposited, and that will occur, by the way, when wind speeds slow down. So faster winds pick up more sand, and slower winds will allow the sand to be dropped. And when the sand gets dropped, we get we get depositional features. So the depositional feature depends a little bit on factors such as what is the coarseness of the sand? Is it large sand grains, which we call coarse sand, or is it very tiny sand grains, which we call fine sand? Well, fine sand can only make up or make slopes of around 35 degrees or so if dry. So dry, fine sand, pretty low angle. If we have coarse sand, we can make an even steeper angle. Well, the funny thing about sand is that it acts differently when it's wet than it does when it's dry. Well, in the desert environment, we're dealing largely with dry sand being moved, but on occasion, we do have moisture there. And we know that if you do have moist sand, well, you can build a steeper angle. Think about making a sand castle. You wet the sand to make the steeper features. If that sand was completely dry, you couldn't make a vertical face out of it at all. And if the sand is too wet, it just acts like mud, basically, and you can't build any kind of pile out of it at all. What we're going to see in the desert with the dry sand, usually fine to medium sand, we're going to see quite a bit of slope or sloped features that represent sand being moved along by the wind and then deposited when wind patterns either die down or maybe two different wind patterns come together, or maybe multiple wind patterns come together to decrease the velocity of the wind. So what we see in a case like this, we're going to get features that, depending on the moisture content, depending on the grain size, are going to have specific slopes to them, with a shallower slope downwind and a steep slope on the uphill, what we call slip face. One of the most famous types of features would be a sand dune like this crescent dune or Barkan dune as an individual feature here. So let's look at the different types of dunes that we might find. And depending on your sources, you might find multiple sources that say, well, there's 6 types of sand dunes. Some that say there's 3 types of sand dunes. They're basically grouping things together or splitting them apart. We see that a lot in science. Depends on if you want to be a splitter or a grouper. Basically, you can divide things up into multiple ways. But this way of 4 types of sand dunes is pretty well accepted as viable. So we're going to talk about the Barkan or crescent dune. We'll talk about longitudinal dunes, transverse dunes, star dunes. And to tell you the truth, we do get all these in California, but the most common ones we'll see will be the crescent dunes and the transverse dunes, which are basically accumulations of crescent or Barkan dunes. The purple arrows here are showing the wind direction or wind directions, plural, and that's going to be key to the type of dune that would form ultimately. So the first one, a Barkan or crescent dune. This is, if you were to draw a sand dune, this would be the one you would probably do. So it's called a crescent dune because it has a crescent shape. Well, a crescent, kind of like the quarter moon shape, which we would call a crescent moon. Or think of the bread product, a croissant. So it's croissant shaped. So basically, a crescent dune has wind moving in one prevailing direction with a more shallow windward face and the slip face being much more steep. The wind moving in this diagram from left to right. So Barkan or crescent dune, probably the one you would think of the most when thinking of a sand dune. Now we also get crescent dunes that create a field. They're basically connected to one another. And when we get them in lines, parallel lines, we then refer to them as transverse dunes. So it'll be a Barkan dune, another Barkan dune, with the wind in this direction, or in this case, moving from the right to the left, but with multiple dunes all joining up. But they are perpendicular to the wind. So they line up parallel to one another, and that parallel nature is perpendicular to the wind direction. We would call those transverse dunes. Now, we can only get these forming when we got an abundant supply of sand downwind. Otherwise, it wouldn't be enough to create so many dunes like this. Third type of dune is referred to as a longitudinal dune or a seaf dune. We use the term longitudinal more often in the western states here. So basically, we have these long lines of dunes, and in this case, we have a wind direction coming in from one direction, tangent to another direction. And cumulatively, these would run parallel to the dune lines themselves. So in this case, the wind would be running either up and down in this photograph or the other way around. So basically, we have a prevailing wind direction that is parallel to the line of dunes themselves. So unlike our last dunes, where they would line up perpendicular to the wind direction, these dunes are lining up parallel to the prevailing wind direction. And lastly, star dunes, multiple wind directions sometimes give a star-like feature. I'm not going to highlight those so much, but basically these do occur where we have a central peak and multiple ridges coming from them. In this case here, they're beautiful from the air. So an aerial photograph would show this central peak with multiple arms radiating away from them. If you get a chance to go explore these, we do have them in California, in the southeast portion of the state. And like most dunes, of course, when you go explore, water, shade, and good transportation out as good as it was coming in. So you always remember, in arid environments, things get cold at night, very hot during the day, but always, always dry.